Hello, welcome to another class. We are going to continue the topic differentiation, and we are going to look at the equation of a tangent and also the equation to a normal to a curve. So, start with what is maybe the tangent. A tangent is a straight line that touches the curve at a given point. So that is what a tangent is. And for us to be able to get the equation of the tangent, we need to have the gradient of that tangent. And the gradient of a tangent is the same as the gradient of a curve at that given point. So how do you get the gradient of a tangent or the gradient of a curve? Number one thing that you need to do is to get the gradient function. You differentiate that particular function to get the gradient function. Then after you differentiate that, when you get the derivative, then you substitute the values of x to get the gradient. So let's look at an example. We see how we can be able to get the equation of a tangent and also later equation of a normal to a curve. So we have example 1. We are to get the equation of a tangent to a curve y is equals to x cubed plus 2x plus 1 at a point 1, 4. So we want to get the equation of a tangent. The curve is y is equals to x cubed plus 2x plus 1. And the first thing to get is the gradient function. So we get the derivative dy over dx of that function. You get you drop 3, you get 3x, then 3 is subtract 1, you get squared, then plus 2 x, we drop it, just get that. So that is our derivative of that particular function. Then to get the gradient, we are going to substitute the values of x. So we have given point as 1, 4. So at point 1, 4, this is the value of x, this is the value of y. So for our derivative, 3x, we replace with 1 squared plus 2, so that you can be able to get the gradient. So 3 times 1 squared is 3 plus 2, you get 5. So our gradient of the tangent is 5. And we have a point where the line is passing, the tangent is passing point 1, 4. So to get the equation, we need to use the formula. Gradient is given by shading y over shading x, where shading y, we take arbitrary point xy, so you get y minus 4, we divide by x minus 1. This one is going to give us the gradient, which is 5. So you cross multiply to get y minus 4, you multiply by 1, which is equals to 5, you multiply by x minus 1. So y minus 4 is equals to 5x minus 5. So I can have this minus 1, we take it on the other side of the equal sign, we get 5x minus 5. So because it is minus and it crosses the equal sign, I'm going to have plus 4. So finally we have y is equals to 5x minus 5 plus 1 is minus 1. So that is the equation of the tangent at that particular point. So look at example 2. So example 2, you have been told to get the equation of the tangent to a curve at the curve is y is equals to x cubed plus 6x squared minus 3x plus 1 at x is equals to 0. So our curve is y is equals to x cubed plus 6x squared minus 3x plus 1. So at x is equals to 0. So the first thing that we need to do here is to ask ourselves, when x is 0, what is the value of y before we go to getting anything else? So that you can be able to get the coordinate of that point that the tangent is passing. So we replace the values of x in our function. So y is equals to x is 0 cubed plus 6 times 0 squared minus 3 times 0 plus 1. So you get this is 0, 0, 0, 1. So y is equals to 1. So our coordinate is 0, 1, where the tangent is passing through. Then you get the derivative of our function dy over dx. You're going to have, we drop 3, get 3, then x squared. Then that one, 6x squared, you're going to have 2 times 6 get 12 x, and then minus 3x, you're going to be having this is power, not times 3 is 3, then x will be x plus 0, so it's going to be like that. That is our derivative of that. Then to get the gradient now, we are going to replace the value of x in this function with the 0, our x value that we have been provided there. So 3 times 0 squared plus 12 times 0 minus 3. This I'm going to get 0, 0 minus 3. So that's our gradient is minus 3. And then we have a point where the curve or the tangent is passing, that is 0, 1. Then you want to get the equation of that tangent. So gradient is given by change in y over change in x. So I get y minus 1 all over x minus 0 is giving us minus 3. So you can put over 1, also multiply, get 1, y minus 1 is equals to minus 3 multiplied by x. X minus 0 is x. So y minus 1 is equals to minus 3x. Then y minus y is equals to, you take minus x on the other side, you get minus 3x plus 1 minus, and close the other side of the cosine is going to be plus. So our equation of the tangent is minus 3x plus 1. So that's how you can be able to get that equation of tangent. So let's look at the normal. What is a normal to a curve? So a normal to a curve is a line that is perpendicular to the tangent at a given point. So in this case, the basic thing to remember here, what to call, is the perpendicular line. And of course we know from Form 2 topic, the equation of straight line, perpendicular lines, their gradients, if you multiply the two, the product gives you a minus 1. So that is the basic thing that we need to remember here. So let's look at an example. You see how you can be able to get the equation of a normal to a curve. We have the first example. We have a curve y is equals to x cubed plus 2x plus 1. I want to get the equation of that normal at a point 1, 4. So first thing, we get the derivative dy over dx. So get 3x squared plus 2. So when you differentiate 3 x cubed plus 2x plus 1, you get 3x squared plus 2. So you get the equation, the gradient of the curve will be 3, our x is 1, squared plus 2, you get 3 plus 2 is 5. So after you get the gradient of the curve, this is the same as the gradient of the tangent, and we have said that the normal and the tangent are perpendicular. So the gradient of the normal now will be get from m1 times m2 gradient of the tangent gradient of the normal, they give you minus 1. So 5 times m2 you get minus 1, then m2 will be minus 1 divided by 5. So that's the gradient of the normal. Then altogether equation, we have the gradient as minus 1 over 5. We have a coordinate where the normal is passing, that is 0.14. So we have a arbitrary point xy. So gradient is changing y over changing x. So you get y minus 4, you divide by x minus 1, give you minus 1 over 5. So cross multiply, you get 5 multiplied by y minus 4 should be minus 1 multiplied by 1 x minus 1. So 5y minus 20 should be equals to minus x plus 1. Minus 1 times minus 1 is plus 1. So 5y b, take minus 20 to the other side, you get minus x plus 1. Then minus 20, when you close the equal sign, the sign to be plus 20. So 5y will be minus x plus 21. 1 plus 20 is 1. Then you can have y is equals to minus 1 over 5x plus 21 over 5. That is the equation of the normal to the curve. Let's see the second question. We have to get to the equation of the normal at a curve y is equals to x power 4 minus 3x squared plus 2x at x is equals to 1. So, and one thing that you need to get is to get the value of y where x is equals to 1. Of course, for us to be able to get the equation, we need to get that coordinate. So let's first get the value of y when x is 1. So y will be x power 4, that is 1 power 4, and then minus 3, x is 1 squared plus 2 times 1. So this is going to be 1 power 4 is 1 minus 3 times 1 squared is just 3, then plus 2. So 1 plus 3 is 3, 1 minus 3 plus 2, that you get 1 minus 1 plus 2, 3 minus 3, you get 0. So when x is 1, y is 0. So the coordinate at which we want to get the equation of the where the normal is passing is a point 1, 0. So when you have that one, you can get now the derivative. So dy over dx would be, you drop 4, you get 4x cubed. Then you drop 2, you get minus 6x power 1. Then 2x, you're going to get plus 2. So that is our derivative of the function. Then we need to get to the gradient at x is equals to 1. So we substitute x cube x with 1. We're going to get gradient will be 4 times 1 cubed minus 6 times 1 plus 2. So this is going to be 4 minus 6 plus 2. 4 plus 2, 6 minus 6 gets 0. So our gradient is 0. That is the gradient of the curve at a point 1, 0 on the gradient of the tangent. Now, we want to get the gradient of the normal. We know that m1 times m2 is given -1. So you're going to have 0 times m2 is going to be -1, then m2 will be -1 over 0. Of course, -1 over 0 is a very big number that any number divided by 0 it's undefined, but we are going to work with it like that for this case. Then this our gradient, the point that the number is passing is 0.10. So you get a little point xy and then have y minus 0 over x minus 1, which is our gradient, is going to give us -1 over 0. Because multiply and have 0 times y minus 0 is equals to -1 multiplied by x minus 1. So this is going to be 0. Number times 0 is 0. Then minus x minus 1 times minus 1 get plus 1. So you have I can take this on this other side, minus x closes the equal sign, I'm going to have positive x is equals to 1. So that is our gradient, that is our equation of the normal of that particular curve at a point 1 or when x is equals to 1. Thank you for your time.